Okay, so now that you have defined the vocabulary for lesson 2.10, we're going to talk about finding a percent decrease first. So we're going to talk about different real life situations. So first example I give you is a coat is on sale, and the original price of that coat is $82. The sale price is $74.50. What is the discount represented as a percent change? So to find a percent change, I'm going to give you a little formula. So percent change is the amount of increase or decrease divided by the original amount. And to represent it as a percent, we'll talk about that later, but that's the percent change. So in this situation, to find the increase or decrease, we're going to take the original amount, $82, minus that $74.50. And then we're going to divide that result by the original amount of $82. So to find your increase or decrease, always take your original amount minus the new amount. So this turns out to be 7.5 over 82. And that is about 0.09, which really is 9%. Okay? So that means the price of the coat decreased by 9%. So that's a 9% discount is what's being represented there. Okay? So take your original amount minus the new amount, divide it by the original amount to get your percent change. So that's a 9% decrease in value. So next, try this next example on your own and then kind of check with me as like a guided practice. So I'll go through this one, but I want you guys to try it, pause the video, and then check your answer with me in a second. Okay, so for this example, we've got to figure out what the original and the new values are. So it talks about the average monthly precipitation for Chicago, Illinois, peaks in June at 4.1 inches. The average in December is 2.8 inches. What is the percent decrease from June to December? So our original value is June, our new value is December. So I take my original 4.1 minus my new value 2.8 is 1.3, and I divide it by my original value of 4.1. So I get roughly 0.32. That represents a 32% decrease. The average precipitation decreased from June to December. So a percent increase is the exact same thing, but we're representing this in a different way. So it's the same formula that we follow, but we just show it in a little bit different way. So in this example, a store buys an electric guitar for $295. They then mark up the price to $340. What is the markup expressed as a percent change? So this is going to be a little bit different, but kind of the same results. So with an increase, this is a little bit different. We're going to do the new minus the original, instead of original minus new, divided by the original amount. Okay? So the only thing that's flipping around is the new value minus the original value. So with this example, I'm going to take the new value of $340 minus $295, and that's out of the original value of $295. So this becomes 45 over 295. I use my calculator to figure that out and round it. It's about 0.15. So this represents a 15% increase in price, a markup of 15%. So the big thing to notice is that these numbers will always be positive. So essentially, one way you can tell if you're kind of doing it right or wrong, you should be getting positive values, hopefully, for these examples. So for a percent increase, it's the new minus the original. For decrease, it's original minus new. But it's finding it always out of that original value. So that stays the same. that it's over the original value. So I want you to try this next example on your own, see if you can solve this, and then check your answer with me in a few seconds. Okay, so for this example, our new price for the toll is $3.50. Our original price for the toll was $3. So I would take my new price, $3.50, minus $3, divided by the original price of $3. So that was 0.5 over 3. I divided and rounded to get 0.17. That is a 17% increase in the price of a toll. So, next, we're going to talk about relative error. And I'm just going to skip to the formula for it, because this is going to be the biggest idea, I guess. So, error. So basically, we've got to know what absolute value means. And it's your estimate minus the actual value. So if you're guessing how far off you are, basically. And then that's always divided by the actual value. How far off are you from the actual value? And this absolute value, remember from before, absolute value is distance from zero, essentially meaning that this relative error, whatever you're off, is going to be a positive value, okay? So I've just got a couple examples to show you about finding percent error. So for percent error in these estimates, absolute value to make sure that it's positive, and then we just got to know what our actual value is and our estimate. So a decorator estimates that a rug is 5 by 8 feet. The rug is actually 4 feet by 8 feet. What is the percent error in the estimated area? So we've got to know area. And if it's rectangular, area is just length times width. So the area of the estimate is 40 square feet. The rug is actually 32 square feet. So we're going to take our estimate of 40 minus the actual area of 32, and then divide it by the actual area of 32. So this becomes the absolute value of 8 over 32, which is just 8 over 32. 8 divided by 32 is going to be, as a decimal, 0.25, which is really 25%. So our percent error was a 25% error. In this next example, I want you to work through it on your own and then see if you can find that percent error. So take a minute, and then I will work through this one and show you how I worked through it to check your answers. Okay, so in this last example, it's important to understand what the estimate is and what the actual value is. In this example, we think the distance is 5.5 miles. The actual distance is 4.75 miles. So I take my estimate, 5.5, minus 4.75. I get 0.75. The absolute value of that is still 0.75. I divide it by my actual distance, 4.75. And I get that I am about 0.16 or 16% off. So I guessed 16% higher than the actual distance. So finding out how far off you are as a percentage, that's percent error. So now you should be ready to move on to the practice and then eventually the checkpoint for this lesson. So make sure that you're working through and showing your work on that practice so that you are successful on the checkpoint. Then after that, you'll be ready to review and take the unit test. So ask me any questions you have on the practice or the checkpoint, and I will address them.